Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to find the evolute of the ellipse x square by a square plus y square by b square is equals to 1. So this is the Cartesian form of the ellipse, correct? And if you remember, the parametric form of ellipse is nothing but x is equals to a cos t and y is equals to b sine t, correct? These are the parametric form of the ellipse, and this is the Cartesian form of the ellipse. You have to remember this in order to solve this problem, and if it is given in the question already, then it is well and good. So first step, what we do here is differentiate with respect to t, this x and y both. So I will write differentiate x with respect to t. So it will become dx by dt equals to, a is a constant as it is cos t. So differentiation of cos is minus sine. So minus, I'll write it here, sine, and t is the angle. Similarly, differentiate y with respect to t. So if we do that, it becomes dy by dt is equals to b, differentiation of sine is cos, then angle t as it is. So what do we have to find? Y1, correct? Y1 is what we have to find. So this is also dy by dx, correct? So how can I find dy by dx? Can I divide dy by dt by dx by dt? I can do that, right? So what I'll do, dy by dt divided by dx by dt. I'll just write it so that it becomes little easier to understand and differentiate. So here I have dy by dt is what? B cos t divided by dx by dt is minus a sine t. Okay, this much it is clear. Now cos by sine is what? Cos by sine is cot. So minus b by a cot t. So we found y1. And now we also have to find y2. That is differentiating y1 again. Okay. And now to find y2, this is also nothing but d square y by dx square. Okay, so we are differentiating with respect to x again. So it becomes minus b by a cot t, right? So most of the times we don't use cot t differentiation, so it becomes little difficult for us to remember the cot t differentiation. So differentiation of cot t, it is nothing but minus cosecant square t. Okay, I'll just write it down here. Cot t, differentiation of cot t is minus cosecant square t. So I can write this as minus b by a is a constant. So I'll write that as it is. And then it will become minus cosecant square t. Now I'm differentiating this with respect to x. With respect to x. So I have t here. So I have to differentiate this t with respect to x again. Correct? So I will differentiate t with respect to x. So here I have dx by dt. Correct? So this dx by dt, what I'll do is I'll take the reciprocal. So if I take the reciprocal, okay, this is just for your understanding, I'm doing reciprocal of dx by dt is dt by dx, which is nothing but 1 by minus 1 by a sine t. So I can write this as y2 minus into minus is plus, y2 is equals to b by a cosecant square t into minus 1 by a sine t. I'm so sorry you couldn't see this. Now this is what b by a is a constant. Differentiation of cot t is nothing but minus cosecant square t. So here and here there is minus, so it becomes plus, and dt by dx is nothing but reciprocal of dx by dt, which can written as minus 1 by a sine t. So till here it is clear. So I can rewrite this as y2 is equals to, minus I'll take it outside, minus b by a cosecant square t. 1 by sine t is what? 1 by sine t is nothing but cosecant t. 1 by sine t, 1 by sine t can be written as cosecant t. So as I have a here, I'll just take it a square here. I'll multiply a into a, it will become a square. So it becomes y2 is equals to minus b by a square cosecant cube t. Done. So y2 we got the differentiation. We know that x bar is equals to x minus y1 by y2 into 1 plus y1 square, correct? And y bar, okay, is equals to y plus 1 plus y1 square divided by y2. So now it becomes, I'll just, y1 and y2 we have found, right? We already have those values. y1 is here, and y2 is here. So using these value, we will substitute this in the in this circle of curvature formula or equation. So x bar is equals to, x is what? A cos t, parametric form, right? A cos t. So I will write it a cos t minus y1 is what? Y1 is minus b by a cot t into minus b by a cot t divided by y2 is what? Minus b by a square cosecant cube t, correct? Into 1 plus this 1 plus y1 square it is. So what is y1? Y1 is minus b by a cot t. So the square that can be written as minus b by a cot t the whole square, correct? I'll take the next page for the continuation of this problem. So now it becomes x bar is equals to a cos t minus, I'll write down this b by a as it is only, minus b by a cot t divided by minus b by a square cosecant cube t, okay, into, I'll just take this square, 1 plus minus b into minus b, like minus b square, it becomes b square by a square into cot square t, correct? Till here it is simple. Now we will go further. What we will do is a cos t minus this cosecant cube t. What I can do, I can write this as, okay, square and a will get cancelled, minus b and minus b will get cancelled, so I have a left here. So it is a cosecant cube t. So I can write this as a sine cube t, correct? I'll just write it down here. What I have done is 1 by a cosecant cube t, I have written as a sine cube t, okay? So a sine cube t into, I have cot t here. So cot t can be written as cos t divided by sine t, correct? Now whatever I have here, I'll just write it down. 1 plus b square by a square cot square t. Done. So now it will become x bar is equals to a cos t minus a sin t, and this cube will become square, it will get cancelled. So minus a sin square t cos t, and then whatever I have here, 1 plus b square by a square cot square t. I'll just multiply this inside. Okay, I'll just multiply this inside. So what it will become, we will see. X bar is equals to a cos t minus a sin square t. This I'm multiplying it with 1. So a sin square t cos t plus, I'll multiply this entirely with this term now. So it will become a b square by a square sin square t cos t into cot square t. Correct? Now here square and a will get cancelled. Square and a will get cancelled. So it becomes a cos t minus a sin square t cos t plus b square by a. Sin square t I have here and cos t. So I will write that as it is. Okay, and cot square t can be written as cos square t divided by sin square t. So sin square t and sin square t will get cancelled. So it will become a cos t minus a sin square t cos t plus b square by a cos t minus cos square t. Sorry, this is not minus, this is into, correct? This is into. So it will become cos cube t. So I'll just scratch it down. Slight misunderstanding. I will take a cos t common from these two terms. So it will become a cos t, if I take common, 1 minus sin square t, correct? Minus b square by a, this is cos cube t. Clear till now? So I will just write it. We know the formula 1 minus sin square theta is nothing but cos square theta. Using this formula, using this trigonometric identity, what I will do is a cos t into 1 minus sin square t. Using this trigonometric identity, I can write it as cos square t minus b square by a cos cube t. So x bar, it will become a cos cube t minus b square by a cos cube t. I am explaining with step by step in with every detail of the expansion or differentiation or simplification, so that you do not get confused at any point. Okay, so till here we have found it. Now what we have to do next is x bar is equals to, this can be written as, I will take cos cube t here common. If I take cos cube t common, what I have is a minus b square by a. This is the common. So I can write this as x bar is equals to, I'll cross multiply, so it will become a square minus b square whole divided by a into cos cube t. So hence I will consider this as my equation 1. Now we have to find y bar, which is nothing but, we already know the formula, right? Y bar can be written as y bar is equals to y. So what is y? Y is b sin t. So I'll just write it. Y is b sin t. And then plus 1 plus y1 square. y1 square is what? Y1 square is what? Minus b by a cot t. So it will become the whole square. So minus b by a cot t the whole square divided by, so this whole divided by y2. What is y2? Y2 is minus b by a square cosecant cube t. Okay. Now what I can do is b sine t minus, here I can just take the reciprocal of this. So if I take the reciprocal of this, it will become reciprocal of this. So it will become minus b by a will become minus a square by, sorry, minus b by a square cosecant cube t will become minus a square by b, and 1 divided by cosecant cube t. Correct? Now this can also be written as a square by b into 1 by cosecant cube t can also be written as what? Sine cube t. I hope this is clear. So I'll just write minus a square by b sine cube t into 1 plus b square by a square cot square t. Okay. This can be further simplified to b sine t minus a square by b sine cube t, and here I can write this term as a square by b sine cube t multiplied by 1, so it will give me this, plus minus into minus is minus, and I'll multiply this with this, so it will give me a square by b sine cube t into I'll just write it down here, b square by a cot square t. Okay, this is the multiplication. I'll just rewrite this into a new page clearly so that you won't get confused. Okay, so this is nothing but b sine t minus a square by b. I'm just multiplying this inside, okay, inside this. So a square by b sine cube t, minus into plus is minus, so a square by b sine cube t into b square by a square cot square t. Okay, I hope it is clear till now. So it will become b sine t minus a square by b sine cube t. So a square and a square will get cancelled, square and b will get cancelled, so it will give me minus sine cube t into, here only this square got cancelled, so I have this b into cot square. I can write it as cos square t divided by sine square t. So sine square t and cube will get cancelled. So it becomes b sine t minus a square by b sine cube t minus b sine t cos square t. Till here I hope it is understood. Now here b sine t and b sine t can be taken common. So I'll take b sine t common and I'll take 1 minus cos square t minus a square by b sine cube t. And if you remember, 1 minus cos square theta can also be written as sine square theta. So I'll just write it as b sine t into sine square t minus a square by b sine cube t. So I can write this as b sine cube t minus a square by b sine cube t. So sine cube t and sine cube t, I can take it common. Sine cube t, if I take it common, b minus a square by b. So I can write this as sine cube t into b square minus a square divided by b. This can also be written as y bar is equals to b square minus a square divided by b into sine cube t. Now y bar can be written as minus of a square minus b square divided by b into sine cube t. Correct? This I will take it as equation 2. Now we have to remove, we shall eliminate t from equation 1 and 2. Okay, so in order to eliminate t from equation 1 and 2, to eliminate t here, what are we aiming? We have cos, sine and cos in both the equation, right? In equation 1 and 2. So I am aiming, okay, or we are aiming to add cos square t and sine square t. So we already know that if we add cos square t plus sine square t, then it will become 1. 1 is a constant, so by default the t will get eliminated. So in order to do this, what I can do is square on both sides of both equations 1 and 2. Okay, and plus and rise power of 1 by 3 both sides of both equations 1 and 2. I hope this is clear. I'll tell you what I mean by this. Okay, my equation 1 is nothing but x bar equals to a square minus b square divided by a into cos cube t. So by what I'm meaning by this is I'm squaring, right? I'm squaring this and raising to the power 1 by 3 both sides. So what will happen? A square minus b square divided by a, squaring and raising to the power 1 by 3 cos cube t. So what I'm doing, squaring and raising to the power 1 by 3 into t. Similarly, I can do it for y dash is equals to, what is y dash? Minus a square minus b square divided by b sine cube t. So after squaring and raising to the power 1 by 3, it will become minus, as I'm squaring, so this will become plus. So it will become a square minus b square divided by b square raising to the power 1 by 3 into sine cube into 2 by 3 t. Okay, now it become x bar to the power 2 by 3 is equals to, I'll just a square minus b square whole to the power 2 by 3 divided by a to the power 2 by 3 cos cube and cube will get cancel square t. This will become y bar to the power 2 by 3 is equals to a square minus b square to the power 2 by 3 divided by b to the power 2 by 3 sine square t. Now it will become a x bar whole to the power 2 by 3 is equals to a square minus b square whole to the power 2 by 3 cos square t. Okay, and now b y bar to the power 2 by 3, just cross multiplying, okay, is equals to a square minus b square whole to the power 2 by 3 sine square t. What is my aim? I'm aiming to add cos square t and sine square t. So what I'll do, I'll simply add these equations, okay? I'll simply add these equations. So it will become ax bar to the power 2 by 3 plus by bar to the power 2 by 3 is equals to a square minus b square cos square t plus a square minus b square sine square t. I can take a square minus b square common. So if I take this common, what I will get, a square minus b square to the power 2 by 3 to the power 2 by 3, which I missed it. So to the power 2 by 3 I can take it common. So cos square t plus sine square t. So this I can write it as 1. So a x bar to the power 2 by 3 plus by bar to the power 2 by 3 is equals to a square minus b square whole to the power 2 by 3 into 1. So this is the evolute. So I can write it as, this is the required evolute. Sorry, I'm so sorry. Evolute. So I will rewrite this in the red pen, so it will be like colorful. Ax bar to the power 2 by 3 plus by bar to the power 2 by 3 is equals to a square minus b square whole to the power 2 by 3. Required evolute. Thank you so much for watching. If you like this video, don't forget to subscribe, share it with your friends, like it, comment it if you have any doubt. Do not forget to support me. If you support me, then I can motivatedly post more and more videos and help you guys like in a better way. Thank you so much.